Hi, algebra classes. We're going to take a look at the 9.6b guided practice problems, and this is where we're going to start practicing using all those techniques that we learned for how to solve quadratic equations. Remember, 5 ways to solve an equation that's in quadratic form. Square root or factoring, complete the square or graph it, and when all else fails, use the quadratic formula. So we're going to start by practicing the first technique we learned to solve quadratic equations, and that's solving by factoring. So that's guided practice 1 and 2. Guided practice 1 presents us with the equation 4x squared plus 8x equals 0. And so what we're going to do is we're going to use some greatest common factoring here in order to break this equation down so that we can use our zero product property and solve it. So we can factor out 4x. You can divide 4x squared by 4x, and you can divide 8x by 4x. So I'm going to factor that out, and then using that distributive property in reverse, 4x times x gives us 4x squared, and 4x times 2 gives us our 8x. So we now have two factors equal to 0. We can set each of those factors, 4x equal to 0, and x plus 2 equal to 0, and solve both of those linear equations separately to arrive at the two values that solve this quadratic equation. So 4x equals 0, divide both sides by 4. Remember, 0 on the top, okay. 0 on the bottom, no way. So since 0 is on the top, we will get 0 for our result. Over here, we are subtracting 2 on both sides of the equation to solve the x plus 2 equals 0 equation to arrive at the second value of x as negative 2. All right, that was solving by factoring using greatest common factoring. In guided practice 2, we're going to use both greatest common factoring and quadratic factoring. We always start by looking to see if our equation can be factored using greatest common factoring, and if that works, that is our first step. It doesn't always work, but when it does, we want to do that first. Our second step will be after we've done any greatest common factoring, we'll use our quadratic factoring techniques that we've learned about. All right, so here's our second equation using factoring to solve the quadratic equation. First, factor out 5, because 5x squared, 15x, and negative 50 can all be divided by 5. So 5 times x squared is 5x squared, 5 times 3x is 15x, 5 times negative 10 is negative 50. So I have successfully factored out 5 from this original equation. Now, we're still equal to 0, and I can divide both sides by 5 at this point, and that 5 will be gone forever. It's fine to divide by a constant, that is a number, so that you can simplify your equation. We wouldn't want to be dividing by x. If this was x, we wouldn't want to divide it out because then we're throwing away one of our possible solutions. But it's fine to divide by a constant, a number, to simplify our equation on both sides. So we're left with x squared plus 3x minus 10 equal to 0. 0 on the top, okay. 0 on the bottom, no way. Now we have a quadratic trinomial to factor into x plus 5 times x minus 2. We know that's true because our inside 5x plus our outside negative 2x does combine to make 3x, and 5 times negative 2 is negative 10. Then we set each of these factors equal to 0, solve those equations, and x is equal to negative 5 or 2. So in guided practice 2, we practiced using both greatest common factoring as well as quadratic factoring. We use whatever factoring works on a particular equation when we're using the factoring method. Then in practice 3 and 4, we're going to practice with solving by taking the square root. That was the second technique we learned in solving our quadratic equations. This works great if you just see an x squared term and no x term. If you have both x squareds and x's, this technique won't work. But this equation is uniquely suited to solving by taking the square root. So our first step, we're going to add 3 to both sides, giving us 7x squared equals 21. Divide both sides by 7, giving us x squared equals 3. And then we're going to take the square root of both sides, and we'll get x is equal to positive or negative 1.73. Now I've used my calculator to work out my square root of 3, and I've rounded to the nearest tenth here. Second problem where we're practicing taking the square root. Again, we have an x squared term. That stuff in the parentheses squared is our x squared term. So again, we can use the technique of taking the square root to solve this equation. Start by dividing both sides by 6. And that's what I'm doing here. Dividing both sides by 6. I've written this twice. I probably didn't need to do that, but here I am dividing both sides by 6, and x minus 3 squared is 5. Now it's time to take the square root because the squared term is by itself. That's going to give us x minus 3 is equal to positive or negative root 5. We're going to add 3 to both sides, giving us 3 plus or minus the square root of 5. Now it's calculator time. to figure out what 3 plus the square root of 5 is and what 3 minus the square root of 5 is. So here I have written down the approximation for the square root of 5, worked out both of these computations here to arrive at x is 5.24 or 0.76. Okay, guided practice 5, solve by completing the square. That was another technique we learned and useful to solving our quadratic equations that led us right up to the quadratic formula. So here we have an equation x squared minus 12x equals 18. We're going to complete the square by opening up a box plus box on both sides. To figure out what goes in that box, we're going to cut that x term in its coefficient, negative 12, that x term's coefficient. We're going to divide it by 2 or cut it in half. That gives us negative 6. Negative 6 squared then will be the number we'll put in both these boxes. We've just built a perfect square trinomial here, and now we're able to rewrite this perfect square trinomial in square form, bring that minus 6 down into the parentheses for that binomial that you're squaring, and 18 plus 36 is 54. Now it's time to take the square root of both sides, and we get x minus 6 equals to positive or negative root 54. Add 6 to both sides, and we get x is equal to 6 plus or minus root 54. We're going to break that into 2 separate computations to work out, 6 plus root 54 and 6 minus root 54. Here I am using my calculator to work both those out, and this is what it's going to show on my calculator, all those digits. But again, our protocol is round to the nearest hundredth, and so here that 4 is rounded up to 5 because of this 8, and here this 4 rounds up to 5 because of that 8. So our answers are 13.35 and negative 1.35 rounded to the nearest hundredth. All right, now we're practicing solving by graphing. To solve by graphing, take our equation that's equal to 0, and we think of it as the equation, instead of being equal to 0, equal to y, so that we can graph this equation and find the x-intercepts. So first, use your algebraic technique of finding the zeros of the function by factoring into the product of 2 binomials, setting each of those factors, both of those binomials, equal to 0, and solving those linear equations and finding that x is either 8 or negative 2 in solution to this. Now let's see what that means on our graph. Well, to make our graph, we need a table of values. We're going to choose negative 2 and 8 for our biggest and our smallest values in our table of values, because we know that they match to y is 0. And then we want the number exactly halfway in between to get our vertex x value. So here I am adding negative 2 plus 8, the zeros of the function, dividing by 2, averaging those two numbers to find exactly what the number in between, which is 3. Notice 3 plus 5 is 8, 3 minus 5 is negative 2, verifying that 3 is exactly halfway between negative 2 and 8. I already know that when x is negative 2, y is 0. When x is 8, y is 0, because I worked that up here when I found the zeros of the function. All I have to work out is what is the value of y when x is 3. So here I'm working that out. When x is 3, y is negative 25. And then I graph these 3 points. I have a beautiful parabola here. And there's the zeros of my function. And by this graph now, based on the x-intercepts, I can claim that my quadratic equation solution is x is equal to negative 2 or 8, because that's the zeros of the function. Finally, our quadratic formula, solved by using the quadratic formula. So we're presented with an equation in standard form, quadratic equation in standard form. And we're going to remember our quadratic formula here. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're going to plug in our a, our b, and our c number. We pull that right off of our standard form quadratic equation here. And we're going to end up with x equals the opposite of b, which is negative 8 plus or minus the square root of b squared, which is 8 squared, minus 4a. A is negative 3. C is negative 2 all over 2a. A is negative 3. Okay, we plug all our numbers in exactly the way they need to fall right into this quadratic formula. Then we begin simplifying. 8 squared is 64 minus a negative times a negative will end up being a subtraction problem, because a negative times a negative times a negative is a negative, so we are subtracting. Or you can think of it as 4 times negative 3, negative 12 times negative 2, positive 24, so we're subtracting 24. So either way you think about it, you're going to end up subtracting 24 from your 64. The negative 8 and the negative 6 are going to stay there. The negative 6, of course, comes from that 2 times negative 3. And then we simplify 64 minus 24, that's 40. And then we're going to break this apart into 2 separate computations, negative 8 plus root 40 over negative 6, and negative 8 minus root 40 over negative 6. We're going to key all of that into our calculator, and this is what it's going to look like when we key all of that into our calculator. And then we'll round to the nearest hundredth. The 7 rounds up to 8 because of the 9, and this 8 rounds up to 9 because of the 7. And we have now solved this equation using the quadratic formula. So in this guided practice, we are practicing with all of the different strategies we have learned to solve quadratic equations, and there's 5 different ways. Factoring, taking the square root, those are the easy methods that we want to use when they work. Completing the square and graphing are other techniques that are useful depending on our particular goal and aim, but typically if we want just an efficient solution, if we can factor or take the square root, we're going to do so. And finally, if either factoring or taking the square root doesn't work and we're wanting to be efficient in solving our equation, we're going to jump to that quadratic formula. Okay, that's it for our guided practice. Now it's time to start the worksheet for your homework, where we're practicing all of these different techniques in solving our quadratic equations. All right, we'll see you next time.